first you can see introduction to trigonometry. Introduction to trigonometry and total weightage here. How many marks? 6 marks. Total weightage 6 marks. 1 mark, 1 question. 2 mark, 1 question. And another question, 3 mark, 1 question. So total 3 questions and 6 marks. 1 mark, 1 question. If you come, 1 mark, 1 question. 2 mark, 1 question. 3 mark, 1 question. And total 6 marks. And total number of questions are 3 questions. Okay. So this is the weightage. So important terminology in trigonometry. What is trigonometry? What is trigonometry? Trigonometry is a Greek word. In Greek, tri means 3. Gono means size. And metry means measurement. 3 size measurement is called trigonometry. So whole trigonometry depends upon right angle triangle as well as Pythagoras theorem. Can anyone state Pythagoras theorem? Pythagoras theorem. Pythagoras theorem states that in any right angle triangle, a square of hypotenuse is sum of squares of other two sides. For example, ABC is the one right angle triangle, and it is right angle at B. Right angle at B, and the angle theta forming at C. Angle theta forming at C. Therefore, this AB is opposite to theta. This is opposite side, and this is adjacent. So adjacent side, or you can call base, and this AC is hypotenuse side. AC is hypotenuse. So what Pythagoras theorem states? In any right angle triangle, a square of hypotenuse is sum of squares of other two sides. AB square plus BC square. AC square is equal to AB square plus BC square. Okay. The next trigonometric functions. How many are there? 6 are there. Correct. First one is sine. SINE, sine theta. Next one, cosine theta. Cosine theta. Next one, tangent theta. Tangent theta. Next one, secant theta. Secant theta. Next one, cosecant theta. Cosecant theta. And next one, cotangent theta. Cotangent theta. So these are the 6 trigonometric functions. 1, 2, third one, fourth one, fifth one, and sixth one. 6 trigonometric functions. So in short, this sine we can call it as SIN, sine theta, and cosine, cos theta, and tangent, tan theta, and secant, sec theta, and cosecant, cosec theta, and cotangent, cot theta. Sin theta, cos theta, tan theta, sec theta, cosec theta, cot theta. Am I right? And cotrigonometric functions. Sin theta is the reciprocal of cosec theta. Sin theta is the reciprocal of cosec theta. Vice versa. Cosec theta is reciprocal of sin theta. So similarly, cos theta is the reciprocal of sec theta. Cos theta is the reciprocal of sec theta. So sec is reciprocal of cos, vice versa. Okay. So tan theta is reciprocal of cot theta, and cot is reciprocal of tan. Then some important relations. See, tan theta we can express in the form of sin and cos. That is, tan theta is equal to sin theta upon cos theta, and cot theta is equal to cos theta upon sin theta. Okay. So there are 6 trigonometric functions: sine, cos, tan, sec, cosec, cot. And trigonometric functions: sine is the reciprocal of cosec, and cos is the reciprocal of sec, and tan is the reciprocal of cot. And tan we can express in the form of sine and cos. That is, tan theta is equal to sin theta upon cos theta, and cot theta is equal to cos theta upon sin theta. Okay. The next Trigonometric ratios. Trigonometric ratios. Imagine there is one right angle triangle ABC. Right angle triangle ABC. Okay. Angle forming at C, that is theta, and right angle at B. Okay. So now, how can we express sine? Sine theta is equal to opposite upon hypotenuse. Sine theta is opposite upon hypotenuse. Cos theta adjacent upon hypotenuse. Tan theta opposite upon adjacent. Cosec theta hypotenuse upon opposite, and sec theta hypotenuse upon adjacent, and cot theta adjacent upon opposite. Okay. See here. In a right angle triangle ABC, right angle at B, and theta formed at C. Theta formed at C. And the AB side is opposite side because theta formed at C. AB is opposite side, and BC is adjacent side, and AC is hypotenuse. This is hypotenuse. Okay. So now sin theta is equal to AB upon AC. AB upon AC. And cos theta is equal to BC upon AC. And tan theta is equal to opposite upon adjacent AB upon AC. AB upon AC. Sorry, BC. AB upon BC. And cosec theta, reciprocal of sine, that is AC upon AB. And sec theta, reciprocal of cos, AC upon BC. And cot theta, reciprocal of tan, BC upon AB. So these are the trigonometric ratios, important trigonometric ratios. Okay. So any doubts here? Yes. Then after this, standard angles. Correct? After trigonometric ratios, standard angles. Here function and here theta. Okay. 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, multiples of 15. 15 is also there, but not there in your syllabus. Degree, 90 minus 75. Okay. So sine, cos, and tan, three functions I have to write here. Okay, yes, see, sine 0, 0, sine 30, half, sine 45, 1 upon root 2, sine 60, root 3 upon 2, sine 90, 1. Similarly, cos 0, 1, cos 30, root 3 upon 2, cos 45, 1 upon root 2, cos 60, 1 upon 2, cos 90, 0. See here, when the sine angles are increases, then the values also increases. When the sine function angles are increases, then the sine value is also increases. When the cos function angles are increases, then the values are decreases. See, cos 0, 1, root 3 upon 2, 1 upon root 1 upon 2, 0. It means that sine function value lies between 0 and 1. Sine function value lies between 0 and 1, but cos function value lies between 1 and 0. 1 and 0. The next tan, 0 upon 1, because tan theta is equal to sin theta upon cos theta. 0 upon anything is 0. 1 upon 0 is infinity, or not defined. Okay, 0 upon 1, 0. So cos 30, 1 upon root 3. Cos 45, 1. And cos 60 root 3. And it is not infinite. And cosec is reciprocal of sine, sec is reciprocal of cos, and cot is reciprocal of tan. Okay. Then after this, trigonometric identities. Three identities are there. Trigonometric identities. Identities. First identity, simple one, sin square theta plus cos square theta is equal to 1. And the sub identity, cos square theta is equal to 1 minus sin square theta. Sin square theta is equal to 1 minus cos square theta. Sub identity. Second identity, 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is equal to sec square theta. And the sub identity, 1 is equal to sec square theta minus tan square theta, and tan square theta is equal to sec square theta minus 1. And the third one, 1 plus cot square theta is equal to cosec square theta. 1 plus cot square theta is equal to cosec square theta. So sub identity, cot square theta is equal to cosec square theta minus 1, or 1 is equal to cosec square theta minus cot square theta. So these are the trigonometric identities. Only three you can remember. One is sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta. And 1 plus cos square theta is equal to sec square theta. That's it. Okay. So now you can see the examples. So the first example. First example. If x into tan 45 degree, x into tan 45 degree into sin 30 degree into sin 30 degree is equal to cos 30 degree into tan 30 degree, tan 30 degree. Find the value of x. X is equal to question mark. Find the value of x. X tan 45 degree into sin 30 degree, cos 30, tan 30. Yes, 1. Okay. So x tan 45 is 1. Sin 30, half. Cos 60, sorry, cos 30, root 3 upon 2. Tan 30, 1 upon root 3. So root 3 cancel. 2 cancel. X is equal to 1. Hence your answer is 1. Okay, next question. In the figure ABC, in the figure ABC, in the figure ABC is right angled triangle. In the figure ABC is a right angled triangle. In the figure ABC is a right angled triangle. If angle C is equal to 30 degree, if angle C is equal to 30 degree and AB is equal to 12 centimeter, AB is 12 centimeter, then find the measure of AC. Then find the measure of AC. In the figure, ABC is a right angle triangle. ABC is a right angle triangle. If angle C is 30 degree and AB is 12 centimeter, so ABC and here it is 30 degree. AB is 12 centimeter. Find AC. Yes, root 2. The sine 30 degree. See, here you can use sine 30 degree, correct? Sine function we can take because sine is opposite upon hypotenuse. Opposite is given and asked to calculate hypotenuse. So sine theta is equal to or sine 30 degree is equal to opposite upon hypotenuse AB upon AC and sine 30 is half. Sine 30 is half is equal to AB is 12 divided by AC. Don't know. Cross multiplication. AC is equal to 12 to the 24 centimeter. This is the right answer. Correct? Yes. Will we get the same answer? Okay. Next. If sin theta is equal to 3 upon 5, if sin theta is equal to 3 upon 5, sin theta is equal to 3 upon 5. Cos theta is equal to 4 upon 5. Cos theta is equal to 4 upon 5. Find the value of sin square theta plus cos square theta. Find the value of sin square theta plus cos square theta. Without calculating, you have to tell the answer. Huh? If sin theta is equal to 3 upon 5, cos theta is equal to 4 upon 5, then ask to calculate sin square theta plus cos square theta. Irrespective of angles, irrespective of values, sin square theta plus cos square theta is always 1. Are you getting me? Sin square theta plus cos square theta is always 1. So without thinking next second, you have to write 1. Here are the same. See, 3 square 9, 5 square 25, 4 square 16, 5 square 25, 16 plus 9 25, 25 upon 25 cancel 1. So right answer is 1. Okay. So any doubts here? Next question. Find the value of sin 90 degree. Find the value of sin 90 degree plus tan 45 degree. Find the value of sin 90 degree plus tan 45 degree. Sin 90, 1. Tan 45, 1. 1 plus 1. Simple example. Next. If tan square theta is equal to 8 upon 7. If tan square theta is equal to 8 upon 7. 8 upon 7. Where theta is an acute angle. If tan square theta is equal to 8 upon 7, where theta is an acute angle, then find the value of 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. If tan square theta is equal to 8 upon 7, then find the value of 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. Yes? 7 upon 8 is the right answer. 7 upon 8. See here. 1 plus sin theta into 1 minus sin theta is in the form of a plus b into a minus b. You know identities, algebraic identities. A plus b into a minus b is equal to a square minus b square. So in place of a 1 is there and in place of b sin theta is there. A square 1 square 1 minus sin square theta divided by. Similarly, 1 plus cos theta into 1 minus cos theta is also in the form of a plus b into a minus b. So 1 minus cos square theta and 1 minus sin square theta is cos square theta divided by 1 minus cos square is sin square theta. So cos theta upon sin theta whole square. Cos upon sin cos square theta. So here tan square is given. Tan square theta is equal to 8 upon 7. Then cot is reciprocal of tan. 7 upon 8. So the right answer is 7 upon 8. So any doubts here? Okay. Okay, next question. Find the value of find the value of 5 times square of tan A. Find the value of 5 times square of tan A minus 5 times sec square A sec square A plus 1. Find the value of 5 times square of tan A minus 5 times of sec square A plus 1. 2. Yes, 2 is right answer. 2. 2. Are you sure? 6. 5 is there. 5 into tan square A minus sec square A. 6. Yes, again, anyone? Yes, you have to revise the identities. 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is equal to sec square theta. Am I right? And 1 is equal to sec square theta minus tan square theta. Huh? So here 1 plus tan square theta is equal to sec square. In place of sec square, what I will take? 1 plus tan square. 5 into bracket tan square A minus 5 into, in place of sec square, I will take 1 plus tan square A plus 1. It's now 5 tan square A minus 5 ones are 5 plus into minus minus 5 times of tan square A plus 1 plus 5 tan square A minus 5 tan square A get cancelled. Minus 5 plus 1. 1 plus tan square theta is equal to what? 1 plus tan square theta is equal to what? Sec square theta. So in place of sec, we have to take 1 plus tan square. Yes, sir. Your minus is there. Minus 5 on the minus 5 because our side is minus. So answer is minus 5. Who got this answer? No one. Very good. Yes, next. What is the value of? What is the value of? Simple one. Tan A into cot A. What is the value of tan A into cot A minus cos A into sec A? Cos A into sec A. What is the value of tan A into cot A minus cos A into sec A? Yes, anybody? 0. 0, correct? Reciprocal of tan is cot, get cancel 1, and reciprocal of cos is sec, get cancel 1, 1 minus 1, 0. Simple. One more questions. Yes, sir. Two more questions you can take now. Show that show that sec to the power 4 theta. Show that sec to the power 4 theta sec to the power 4 theta minus sec square theta is equal to tan square theta plus tan to the power 4 theta. Sec to the power 4 theta minus sec square theta is equal to tan square theta plus tan to the power 4 theta. Prove that. Prove this one. It's simple. Don't take much time here. LHS side you can take first. LHS side is sec to the power of theta minus sec square theta. So sec square is common, take it outside. Sec square theta and remaining terms inside the bracket. Sec square theta minus 1. But the right hand side is in the form of tan. RHS in the form of tan. We know the identity, second identity. 1 plus tan square theta is equal to sec square theta. So in place of sec square theta, I want to write 1 plus square of tan theta or tan square theta. And sec square theta minus 1 is nothing but tan square theta. So tan square theta, now I will multiply this tan square to this bracket, tan to the power 4 theta, sorry, square theta plus tan to the power 4 theta. Hence, the proof, it is your RHS. 2 marks, simple question, note down, fast. Next question. Any doubts here? Next question. If root 3 times tan theta, if root 3 tan theta is equal to 1 and theta is an acute angle. If root 3 times tan theta is equal to 1 and theta is an acute angle, find the value of sine 3 times theta plus cos 2 theta. If root 3 times tan theta is equal to 1, comma sine 3 theta plus cos 2 theta is equal to question mark. Yes. Simple. What is the answer? 3 by 2. 3 upon 2. Okay, see here. Tan theta is equal to 1 upon root 3. Tan theta is equal to tan 30 degree. Am I right? Tan 30 is nothing but 1 upon root 3. If the functions are equal, then angles also equal. So theta is equal to 30 degree. Substitute 30 degree here. Sine 3 into 30 plus cos 2 into 30. 33 is a 90. Sine 90 degree plus cos 60 degree. Sine 90 is 1. Cos 60 is cos 60 1 upon 2. So 2 plus 1 upon 2 is equal to 3 upon 2. Okay. Yes, next question. Prove that. Prove that. Sine A, sine A divided by 1 minus cot A, 1 minus cot A plus cos A divided by 1 minus tan A, 1 minus tan A is equal to sin A plus cos A, sin A plus cos A. Take LHS and through RHS. 3 mark question. Model question paper number 1, 2021. Sin A 1 minus cot A. First, let's just left hand side. Sin A 1 minus cot A plus cos A divided by 1 minus tan A. Okay. So sin A divided by 1 minus this cot I can write in the form of sin and cos because the right hand side is in the form of sin and cos. So cot is cos A upon sin A plus cos A divided by 1 minus sin A upon cos A. In denominator, I need to take LCM. So it is 1 and here also 1. 1 sin A. LCM is sin A. Numerator write as it is sin A divided by 1 sin A is a sin A minus cos A divided by sin A plus cos A whole divided by cos A minus sin A divided by cos A. Am I right? Yes, now sin I can take to the numerator. Sin into sin, square of sin A or sin square A. Sin square A divided by sin A minus cos A. Sin A minus cos A plus this cos I can take to the numerator. Cos into cos, cos square A. Cos square A divided by cos A minus sin A. Cos A minus sin A. So you can see the denominators. Here sin A minus cos A, but here cos A minus sin. Not same. So what I need to do? I need to take minus sign as a common and it becomes sin A minus cos A. In that case, both the numerators are same, equal. So sin square A divided by sin A minus cos A minus, I am taking minus sign as a common, cos square A divided by, now it becomes sin A minus cos A. You can see the denominator same, sin A minus cos A, sin A minus cos A. So LCM is also same, sin A minus cos A, sin A minus cos A. Okay. So here sin square A minus cos square A square minus B square. So the expansion of A square minus B square, A plus B into A B plus cos A into bracket sin A minus cos A divided by sin A minus cos A. Sin A minus cos A get cancelled. To remaining term only sin A plus cos A, hence RHS. Got it? Yes, no. Okay, next question. One more, three more question. Do that. Do that. 1 plus cos A. Do that. 1 plus cos A divided by sin A divided by sin A minus sin A divided by 1 plus cos A. 1 plus cos A is equal to 2 times of cot A. 2 times of cot A. Okay. See here. So here, left hand side is in the form of sin and cos, but we need to put right hand side cot. Can you try? Just 1 minute time you can try. Simple. Take LCM. 1 plus cos A into sin A is LCM. 1 plus cos A into 1 plus cos A, 1 plus cos square, cos A whole square minus sin square A. Simplify, you will get the answer. Utturi, one single example also you didn't solve. Correct? Hopeless. Simply coming to school. LHS we can take. LHS is 1 plus cos A divided by sin A minus sin A divided by 1 plus cos A divided by 1 plus cos A. So LCM is sin A into 1 plus cos A. LCM sin A into 1 plus cos A. Here sin A already is there, but 1 plus cos A is not there. You need to multiply with 1 plus cos A. 1 plus cos A into 1 plus cos A, 1 plus cos A whole square minus sin A into sin A, sin square A minus sin square A. So now, yes, will you get the answer? Yes. Okay. So 1 plus cos A whole square, expansion, 1 plus cos square A plus 2 times of cos A minus sin square A divided by sin A into 1 plus cos A. Correct? But we need 2 times of cot A. Yes, sir. Next, cos square A minus sin square A. Cos square A plus sin square A is 1. But we can't take as a cos square minus sin square as 1. 1 minus sin square, that one. 1 minus sin square is cos square. It become cos square. Then cos square, 2 times of cos square. Then 2 is common, take it outside. 2 cos is common, take it outside. You will get the answer. Okay. Yes, sir. 1 minus sin square is cos square A plus cos square A as it is. Cos square A plus 2 times of cos A divided by sin A into 1 plus cos A. Here, cos square plus sin square is not there. Minus is there. Don't get confused. Cos square plus sin square means 1. So that's what 1 minus sin square is cos square. So cos square, 2 times of cos square. 2 times of square of cos A plus 2 times of cos A divided by sin A into 1 plus cos A. 2 cos A is common. 2 cos. 2 times of cos A, remaining term cos A plus 1 divided by sin A into 1 plus cos A. 1 plus cos A, 1 plus cos A get cancelled. 2 write as it is. Cos upon sin, cot. 2 times of cot. This is your RHS. Okay. Any doubts here? Any doubts? No doubts. Yes. Next question. Again 3 marks. One more question. Prove that 1 plus sin A, 1 plus sin A divided by cos A. Same question. 1 plus sin A divided by 1 plus sin A divided by cos A. Cos A minus cos A divided by 1 plus sin A. 1 plus sin A is equal to 2 times of tan A. 2 times of tan A. Same typology. No changes. Take LCM. Yes, sir. LCM is cos A into 1 plus sin A. Cos A into 1 plus sin A. So 1 plus sin into 1 plus sin. 1 plus sin A whole square minus cos square A. And and expansion a square plus b square plus 2 times of sin a minus cos square a divided by cos a into 1 plus sin a. 1 minus cos square is sin square. Same, sin square minus cos square is there. Plus is not there. So 1 minus cos square we have to take. So 1 minus cos square is sin square a plus sin square a plus 2 times of sin a divided by cos a into 1 plus sin a. Sin square 2 times of sin square. So 2 sin square a 2 sin square a plus 2 times of sin a 2 times of sin a divided by cos a into 1 plus sin a cos a into 1 plus sin a. So 2 sin a is common. 2 sin a is common. So here sin a plus 1 divided by cos a 1 plus sin a. Sin a get cancelled. 2 sin upon cos is 2 times of tan a. Okay. This next example. Prove that cos theta minus 2 cos cube theta. Prove that cos theta minus 2 cos cube theta. Cos theta minus 2 cos cube theta divided by 2 times of sin cube theta 2 times of sin cube theta minus sin theta is equal to cot theta cos theta minus 2 times of cos cube theta sin cube theta minus sin theta is equal to cot theta. Yes, anybody? Solved? Very good. Zero, pass it. That's correct. Over. Huh? Not you. That guy. Solved? Yes. Okay, yes, LHS side we can take here. Simple LHS side. Cos theta minus 2 cos cube theta divided by 2 times of sin cube theta minus sin theta. Cos theta is common. Cos theta into bracket 1 minus 2 times of cos square theta divided by sin theta is common. Sin theta into bracket 2 times of sin square theta minus 1. Cos theta upon sin theta, cot theta into bracket. 1 you can write it as sin square theta plus cos square theta. Sin square theta plus cos square theta minus 2 times of cos square theta divided by 2 times of sin square theta, and again I am writing 1 as a sin square theta plus cos square theta, but minus is there, minus sin square theta minus cos square theta, minus sin square theta minus cos square theta, cot theta into bracket sin square theta, right, as it is sin square theta plus cos square minus 2 minus cos square divided by 2 sin square minus 1 sin square, sin square theta minus cos square theta. Sin square theta minus cos square, sin square theta minus cos square theta cancel. Answer is cot theta. 3 mark. Next. Next question. Do that. Do that. Sin theta minus 2 sin 2 theta. Sin theta minus 2 sin cube theta divided by 2 cos cube theta, 2 cos cube theta minus cos theta is equal to tan theta. Same typology of question. The same method we can use here. Same typology, no changes. Okay. Dust. Clean the dust. This next question. Do that. Do that. Sec A. Sec A plus tan A minus 1 divided by tan A minus sec A plus 1 is equal to 1 plus sin A divided by cos A. Textbook example, illustrative example. Sec A plus tan A minus 1 divided by tan A minus sec A plus 1 is equal to 1 plus sin A upon cos A. You can use the identity. Hint I will give you. Hint. You can use the identity 1 plus tan square A is equal to sec square A. This identity you can use here. One plus tan square A is equal to sec square A minus 1. Use this identity and solve the example. See here, LHS is sec A plus tan A minus 1 divided by tan A minus sec A plus 1. And I have given the hint that you can use the identity 1 plus tan square A is equal to sec square A. And 1 is equal to sec square A minus tan square A. 1 is equal to sec square A minus tan square A. 1 is in numerator also as well as denominator also. So which one can you take it as a sec square A minus tan square A? Numerator or denominator? Why numerator? Why? Why numerator? Question is why numerator? Why not denominator? Huh? You should cancel the denominator, okay? But some of the times we are taking denominator, and few of the times we are taking numerator. But why? Huh? See here 1 plus sin A is there, and here sec A plus tan A. If it is sec A minus tan A, then again you need to take this one as a sec square A minus tan square. Depend upon the sign, depend upon RHS. Your whole LHS and whatever the following method is there, that depend upon RHS. Okay. You see here, sec A plus tan A minus 1, sec A plus tan A, and this minus 1, I write it as sec square A minus tan square A. Sec square A minus tan square A divided by tan A minus sec A plus 1. So now sec A plus tan A, right, as it is sec A plus tan A, and minus, this is in the form of A square minus B square. So A square minus B square expansion, A plus B into A minus B. So A plus B, sec A plus tan A into A minus B, sec A minus tan A divided by tan A minus sec A plus 1. Here are two equations. First sec A plus tan A and sec A plus tan A into sec A minus tan A. Sec A plus tan A, sec A plus tan A is common. Take it outside. Sec A plus tan A, sec A plus tan A, and remaining term inside the bracket 1. Sec A plus tan A outside, remaining only 1. Minus sec A outside, remaining sec A minus tan A. 1 minus, again bracket, sec A minus tan A, bracket complete. Okay. So divided by, denominator right as it is, tan A minus sec A plus 1. Tan A minus sec A plus 1. See here, just I have to remove this minus sign as well as this bracket. Multiply this minus sign to this bracket. Sec A plus tan A, right as it is, into bracket 1 minus sec A, minus into minus, plus tan A, whole divided by tan A minus sec A plus 1. 1 minus sec A plus tan A, 1 minus sec A plus tan A get cancelled. Remaining term only sec A plus tan A. Sec A I can write it as 1 upon cos A and tan sin A upon cos A, because the answer is in the form of sin and cos. So LCM is cos A into 1 plus sin. Numerator 1 plus sin. This is your RHS. Okay. Any doubts here? Yes. Next. Two thousand 21 question it is. 2021 model question paper number. Sec theta minus cos theta. Sec theta minus cos theta. Sec theta minus cos theta. Parenthesis is there. Parenthesis. Cosec theta minus sin theta. Cosec theta minus sin theta. Tan theta plus cot theta. Tan theta plus cot theta. Close parenthesis is equal to 1. So that sec theta minus cos theta. Cosec theta minus sin theta. Tan theta plus cos theta is equal to 1. Simple. First write sec in the form of cos, cosec in the form of sin, as well as tan and cot also in the form of sine upon cos, cos upon sine. Take LCM, you will get the answer. Simple example. This LHS, you can take here LHS cos sec theta minus cos theta. Sec I can write as cos 1 upon cos theta minus cos theta into bracket cos sec theta 1 upon sin theta minus sin theta close bracket tan theta sin theta upon cos theta plus cos theta upon sin theta again bracket close and parenthesis also close. So now 1 minus cos square theta divided by cos theta into bracket 1 minus sin square theta divided by sin theta. Here sin theta into sin theta, sin square theta, cos theta into cos theta, cos square theta divided by sin theta into cos theta, sin theta into cos theta. So now 1 minus cos square theta is sin square theta divided by cos theta into 1 minus sin square theta is cos square theta divided by sin theta. Sin square theta plus cos square theta 1 again into sin theta into cos theta. One sin get cancelled. One more sign also get cancelled. One cos get cancelled. Cos get cancelled. One. Okay? Yes. Next question. Prove that prove that under root 1 plus cos A, most repeated question it is. I think 5 to 6 times the same question appeared in the board examination. 5 to 6 times, same question. Under root 1 plus cos A, 1 plus cos A divided by 1 minus cos A is equal to cosec A plus cot A. Cosec A plus cot A. Under root 1 plus cos A divided by 1 minus cos A is equal to cosec A plus cot A. Just rationalize the denominator. And the rationalizing factor is 1 plus cos A. Rationalize the denominator. You will get the answer. Okay. Simple. LHS side you can take first. LHS under root 1 plus cos A divided by 1 minus cos A. And here only I want to rationalize the denominator. So the rationalizing factor is 1 plus cos A divided by 1 plus cos A. 1 plus cos under root 1 plus cos A whole square and 1 minus cos 1 plus cos 1 square minus cos square means 1 minus cos square A. So under root 1 plus cos A whole square divided by sin square A. So just I will write both the numerator and denominator in one bracket. 1 plus cos A divided by sin A whole square. Square root get cancelled. 1 upon sin is cosec and cos upon sin is cot. Cosec A plus cot. Okay. Yes, next. Next question. June 2020. If x is equal to p times tan theta, if x is equal to p p times of tan theta, p times of tan theta plus q sec theta plus q times of sec theta, and y is equal to p times of sec theta, p times of sec theta plus q times of tan theta plus q times of tan theta. Then prove that, then prove that, prove that x square minus y square is equal to p square minus q square. X square minus y square is equal to q square minus p square. Q square minus p square. X is given. X is equal to p times of tan theta plus q times of sec theta. And y is given. Y is p times of sec theta plus q times of tan theta. Prove that x square minus y square is equal to q square minus p square. It's simple. Same here. Prove that x square minus y square is there. No. What is x? Ideal. X square minus y square is equal to x is p tan theta plus q sec theta whole square minus p sec theta, p sec theta plus q tan theta whole square. P sec theta plus q tan theta, p tan theta plus q sec theta whole square. Now a plus b whole square expansion. A square p square tan square theta plus q square sec square theta plus 2 times of pq tan theta into sec theta, tan theta into sec theta. So similarly, we can expand one more equation, that is a minus b whole square minus into brackets p square sec square theta plus q square tan square theta plus 2 times of pq tan theta into sec theta, tan theta into sec theta, make it complete. Okay. So now you can multiply minus sign to the bracket. P square tan square theta plus q square sec square theta plus 2 times of pq tan theta into sec theta minus p square sec square theta plus plus into minus q square tan square theta plus into minus 2 times of pq tan theta into sec theta. Yes, see here, plus 2 times of pq tan theta into sec theta minus 2 times of pq tan theta into sec theta get cancelled. So this one get cancelled. Then the remaining comes p square tan square theta, p square tan square theta plus q square sec square theta minus p square sec square theta minus q square tan square theta. These are the remaining terms. Okay. Here what to do? See, we need q square minus p square. Where is q square? Here tan square is there, and here also tan square is there. But here minus q square and p square. If I take p tan square as a common, see tan square theta. This is p square minus q square. P square minus q square. And similarly, here I take p square as a common plus p square as a common, p square, sorry, again sec square as a common, sec square theta, then it is q square minus p square, q square minus p square. But what do we need? We need q square minus p square. So what I will do, again I will take the minus common, I'll make it as minus tan square theta into p square minus q square, p square minus q square plus sec square theta into q square minus p square. See here minus tan square, q square minus p square, q square minus q square minus p square, q square minus p square common again, q square minus p square common. Remaining term sec square theta minus tan square theta, sec square theta minus tan square theta. So q square minus p square into 1. Because 1 plus tan square theta is equal to sec square theta. Sec square theta minus tan square theta is 1. Hence, x square minus y square is equal to q square minus p square. That's the proof. Okay? Any doubts? No doubt. ಏನು ಮಾಡಿದ್ದು ಗೊತ್ತಾಯ್ತಲ್ಲ, ಗೊತ್ತಾಯ್ತಿಲ್ಲ, everything will be noted. After this class, you will get the punishment. Don't worry. Okay, next question. Prove that. Prove that. Cos cube theta plus sin cube theta. Prove that. Cos cube theta plus sin cube theta divided by cos theta plus sin theta. Cos theta plus sin theta plus cos cube theta minus sin cube theta. Cos cube theta minus sin cube theta divided by cos theta minus sin theta. Cos theta minus sin theta is equal to 2. Is equal to 2. Prove that. Cos cube theta plus sin cube theta divided by cos theta plus sin theta plus cos cube theta minus sin cube theta divided by cos theta minus sin theta. A cube plus b cube, a cube minus b cube identity. A cube plus b cube is equal to, yes, anybody? A cube plus b cube is equal to a plus b into a square minus ab plus b square. And a cube minus b cube is equal to a minus b, a square plus ab plus b square. Correct? Yes. Solve this. This solved. Simple. Identity you can apply. A cube plus b cube identity, a plus b into a square minus ab plus b square divided by cos theta plus sin theta. Cos plus sin theta get cancelled. Plus a cube minus b cube identity, a minus b minus b cos theta minus sin theta into a square plus ab plus b square divided by cos theta minus sin theta. Cos theta minus sin theta. Cos theta minus sin theta. Cos theta minus sin theta get cancelled. And should discretize it. So now cos square theta plus sin square theta 1 minus cos theta plus sorry into sin theta. Cos theta into sin theta plus cos square theta plus sin square theta again 1 plus cos theta into sin theta plus cos theta minus cos theta into sin theta get cancel 1 plus 1 2. Hence the yeah. Yes sir. Today I will write the class. Then I will continue tomorrow. Tomorrow we can see on chapter minus surface areas and values. Okay. Yes, you can go now.